So we're starting by taking a look and seeing how we can find each of these values without having to rely on our calculator. Because the more work that you can do in your head, the more mental math you're able to do, the better off you are in the long run. Because even if you don't do every single one of these that you can do in your head, if you actually go to calculator on some of it, you at least then develop that sense of what's reasonable, what should I expect, what am I looking for. All right, so 125 to the power of 1/3. No, this does not mean to take 125 and divide it by 3. Remember that a fractional exponent actually means a root, a radical. So like what we did on last night's assignment. So I start by turning it into that radical form, and so now I know what I'm actually answering. I'm trying to figure out what is the cube root of 125, or in other words, what number cubed, that is what number times itself 3 times, equals 125. That's one of those values you should be memorizing. You should know that 5 cubed equals 125. All right, so that's our answer, is just 5. Because that's the number that when cubed equals 125. All right, next one, number 4, or the 4 to the 5 halves. Again, I see a fractional exponent. I can't simplify the fraction at all, so I'm going to go straight to putting it into radical form. And this is what we're going to tend to write for radical form. But there's actually a cool little trick we can do here. We can actually do the root and the power in either order. So we can either do the square root of 4 to the 5th, or we can do the square root of 4 to the 5th. The question is really, which one of those two is easier? And so which one would be easier for you to do without a calculator? Is it easier to do 4 to the 5th and then take the square root of that number? Or take the square root of 4 and then raise that number to the 5th? Yeah, I'm thinking it's definitely that second one. Because the square root of 4 is just 2. And I know what 2 to the 5th is. Hopefully you do as well. That's one of those values that I want you to be memorizing because it comes up so often. 2 to the 5th is just 32. And so you notice we can make our lives easier here by actually finding that root first, assuming that it's actually possible to find that root, which, since I'm telling you to do this without a calculator, big hint that you will be able to. All right, so 27, we handle it the same way. I'm going to start by taking my fractional exponent, and I'm turning that into a radical. And again, I could write it either of those two ways, either taking the square root first or the cube root first, or squaring it first. And then it's just a matter of which one's easier. In this case, again, the cube root first is easier. Doing the root first, it's just a much easier way to do it because we end up with a smaller number. I don't know what 27 squared is off the top of my head, but I do know what 3 squared is off the top of my head. And so our final answer here just ends up being 9. So by being able to take these fractional exponents and put them into these radical forms, we then can manipulate them and make our lives much easier. So then now we get into our heavy lifting for today. We're just going to do these 2 problems, and then I'm going to give you some time to actually practice doing these on your own for homework, where we're going to be multiplying radicals and we're going to be dividing radicals. So go ahead and write down that first problem. And the first thing I want to talk about here is what we can't do. Because if I just gave you this problem without any context and said to multiply them through, not knowing the proper techniques, our inclination might be to say, well, maybe I multiplied the 3 and the 9, but that's not going to work for us. And it's probably easiest to explain why we can't do that by showing what we can do here. And the first thing that we can do here is take each of these radicals and turn them into fractional exponents. Seeing as how that's what we've been just learning and just practicing, hopefully that makes sense. So go ahead and start by rewriting each of these as x to the power of a fraction. All right, so when you turn those into fractional exponents, this is what we should get. The first one is x to the 2/3. Because remember, the exponent is our top of our fraction, and the root is the bottom. And then for the second one, it's 1/9, because remember, if it's just x, it's x to the 1 power. So that's why it's 1 over 9 there. All right, so I now have two x's that are being multiplied together. Let me take you on a slight rabbit trail here off to the side. What if I gave you something completely different but simpler? X squared times x cubed. What would that equal? That'd be x to the fifth. Because when we multiply the x's, we add the exponents. We're going to use the same rule here. We're multiplying the x's, and so I'm going to be adding the exponents. It's just that in this case, adding the exponents means adding fractions. So yes, I have to remember how to add the fractions. All right, so if we're going to add the fractions, of course, I need a common denominator. So that means multiplying the first fraction, top and bottom, by 3. Then I can go ahead and add them. So it gives me 7/9. So that tells me that when I add the exponents, it gives me x to the 7/9. Now that I have that as my answer by actually doing the multiplication of the x's, adding the exponents, now I can take my answer and put it back into the radical forms. Because if I start in radical form, I want to get my answer in radical form as well. So now I take my 7/9 and I switch it back to look like this. And so then this is the final answer that you should have found. You should be getting the 9th root of x to the 7th as your final answer there. All right, now we're going to take a look at the other problem as well, the division problem. If you haven't already written it down on your paper, write it down on your paper. All right, and in this case, we are going to be doing division. But before I can do that division, I can't, again, really do it with these two radicals. Just like I can't multiply with the straight up radicals, I can't divide while they're radicals. So first thing you want to do, turn each of those radicals into exponent form. Or in other words, turn them into a fractional exponent. All right, and so when you turn them into radicals, or into fractional exponents, that gives us x to the 5/6 over x to the 1/2. Now we just have to remember that when I divide the x's, what do I do with the exponents? We subtract. So we subtract our exponents here. So I'm going to have to be doing 5/6 minus 1/2 in order to figure out what my new exponent is going to be. Now, since that subtraction process gives us 2/6, yes, I do want you to reduce it because that fraction reduces, so go ahead and reduce it down to be 1/3. So then that tells me that when I divide the x's, it gives me x to the power of 1/3. But again, I'm not going to stop there. Even though I just have one x now, which was my goal, my original problem was given in radical form, so I want to give my answer in radical form as well. So go ahead and turn that into a root, that is a radical. And so you should get an answer here of just cube root of x.